this is another question in the weekly contest 290. Count lattice point inside a circle. Now let's read the problem. So, given two the integers array circles, it has the members of its array is definitions of the circle, while xi, yi are the center of the circle, while the ri is the radius. So that will be this, okay, in terms of the circle. And then return the number of lattice points that are present inside at least one circle. So we have a list of circles, and now they asking about this lattice point. So we need to find the definitions of lattice point. So a lattice point is a point with integer coordinates. Okay. So the nice things about these problems, it gives us some drawings here. So we can see integers means there is no comma, there is no points. So it's like 1, 2, 1, 3, and so forth. So any kind, lattice points here means any kind of integer coordinates. That's it, right? So the requirement is that it should be in at least one of the circle being given as an input. And there is another notice here. If the point is in the circumference, it is considered to be inside the circle. Okay, so we given a list of circle. For example, in this second example, there are two lists of circles. Now we need to find integers numbers that are actually inside the circle. For example, in this example, you see here 1.2, 2.2, 3.2, 2.3. All of these are points with integer numbers, right? And then you see this green color, it is basically saying in this example that those are the lattice points which is inside the circle. There are 5 points there, so the answer is 5. While there are these two in the red colors is an example of lattice points which is not part of the solutions because they are outside of the circles. Now we need to define how to solve this basically. Now the thing is we need to try to translate the definitions of inside the circles, right? How is it to be inside the circle? To be inside the circle, we need to remember some Pythagorean formula that is about the circle itself, right? So a circle is basically defined with a sort of Pythagorean things, that is uh, the square root, any points have to be inside the radius, and a radius when it is slanted is actually can be defined for any kind of point. The distance from the center is basically the square root of its delta with the center. For example, these points 1.3, the distance between here to the center can be defined by the x squared plus y squared and square root of it. So remember that Pythagorean, right? X squared plus y squared equal to this squared. Okay, so remember that the Pythagorean, y squared x squared plus x squared equal to the distance squared. So a point is inside a circle when the distance to the center of the circle is less than equal to the radius of the circle. So for this, for example, this 2.3, it will be the x squared, delta x squared is 0 because it's in line with the center, while the y squared will be the radius itself, which is in this case 1 squared. And 1 squared, so 0 squared plus 1 squared is equal to the radius square, 1 square. So 2.3 is inside the circle. So that is, we need to remember to know these Pythagorean things to be used as a definition whether points is inside a circle. Okay, so that's the key base knowledge to solve this problem here. The Pythagorean, the definition, how to define this, uh, whether it's inside a circle or not, using the Pythagorean. Now, the second things to solve this problem is how do we know what are the points to test, right? What are the points to test? Now, the points to test is basically one of the way is to try every possible integers points. Now, to do that, another points that you need to actually take a notice of in a problem is the constraint. So here we know the constraint that xi, yi will always be positive. Okay, and then the radius is always be between 1 and the minimum of xi, yi. In other words, here the radius, if xi is 1 or ri will be 1, right? Because that's the minimum already. Regardless of how big the y, if xi is 1, ri will always be 1. 1 minus 1, 0. In other words, all the points here are always be above 0. So that's one of the way we can limit our space of search. So the clue in this puzzle is also in the constraint. So remember that when you are looking for something, when there is a big space of search, try to look for the constraint. And then here we know that there could be at most 200 circles. Of course, each circles contain that three informations, right? The centers and the radius. And the points is between 1 to 100. Okay, so here we can limit the space into 1 to 100. Okay, but for this solution, what I'm going to do is another way to also think about the space, even without looking at the constraint, is to search around the circle itself. So we can look at here that every circle can be considered as having these squares, right? And then we can search through this list of points in the square, which is basically a loop between this one will be the center minus r, like the x minus r, comma y, the yi, basically the center y minus r, so that will be this point, and then we can loop it through doing a two level for loop until these points where this is actually xi plus r and yi plus r. So that's another way to find the what do you call that, the list of space to search. Okay, so that's it. That's how we're going to solve this problem. We're going to test for each circles all the possible points, which is we simplify it by considering the squares of it, and then we look through it, and then for each point we're going to test whether it is inside the circles or not. Okay, inside the circles or not, we use the Pythagorean, comparing it with the radius of the circle itself. So that's the two key points to solve this. Let's go to the coding now. I'm using Python here. Now, this is what we're going to return. Basically, this is the counters of the number of lattice points which is inside at least one circle. Okay, and this visited is basically to track whether a circle is a duplicate or not, because nowhere here in this problem that says the circles are unique. So it could be the problem have inefficiency where the same circle mentions multiple times in the circles. Okay, so that's where the visited coming in. Another thing is about the memo here. The memo here is basically to track whether a point is already counting up this or not. We don't want to count it up twice because a circle can be overlapped. When the circle is overlapped, then our space of search is actually going to be doubled. So we don't want to test it again. We don't want even to do the Pythagorean here. Okay, so those are the initializations. Then the logic is like what I said just now. First, we go for each circles, and then this part is actually the check whether the circle is already calculated or not, already visited or not, whether this C is actually a duplicate. Okay, checking whether C is a duplicate basically. Okay, visited because we already calculated all the points that possible for that to be inside the circle, the lattice points. This is the lattice point check then. So this is the way basically to extract a list or a set in Python. So basically each C has three things like the center and the radius. And then here I put it out here to make it more efficient because we don't want to just calculate it again and again. This is the radius squared because remember the Pythagorean, delta x squared plus delta y squared equal to the radius squared. And then this is the space for the points to be searched. So for each x, remember just now that the center minus the radius, that will be the lowest x possible, while the center plus the radius, that will be the highest x possible. This is plus 1 just because in Python it is exclusive. So we want to also reach this. Remember that points in circumference is considered inside the circle, right? And similarly with y, so the yi minus ri is the lowest y, while yi plus ri is the highest y, and this plus 1 because in Python this is exclusive, right? And then this first check is just a check whether this point is already counted the return counter up. Okay, if it is already, then we don't want to calculate another Pythagorean check on that. But if it is not, then we do the Pythagorean check. Okay, the Pythagorean check, basically the delta x squared plus y squared should be less than equal to the radius squared of the circle, which means in that case x comma y is actually inside the circle if the if it is fulfilling these conditions. Okay, and then if it is the case, we count it up, and then we also memorize that hey, this point we already do it. So that's it. Now once it's done, as per usual, we try first with a simple case, and then we check that it is correct with the expected. Then now we submit. We will fail if this is not fast enough. It is turns out to be fast enough. Cool. And one thing to notice here with Python, Python is definitely slower than C, right? So for example, during these competitions, I saw some other people actually creating a solution by leveraging these things as a as a space search, right? So they actually basically looping the x and y from uh, 0 to 200, right? Because the maximum radius, of course, 100, right? When x and y is 100, the mean is 100. So when it is 100, 100, 100, it means the top point is 200. So basically, they loop the x and the y from 0 to 200. And that works. But I copy that, and then I try it in the Python. That doesn't work because there is some unfairness in terms of the language you use when you are doing competition. So if you are uh, really want to win in competitions, you better familiarize yourself with C, because even with a less efficient solution, you might just still pass the time limit. Okay, so that's about it. So if you are using Python, you really need to make sure your solution is actually as efficient as possible, which efficiency here is increased by having this visited circles, and that's it. For memo, actually, it's a must. It's a must. Another things is actually to limit our space of search by looking at the possibility per circle rather than leveraging the constraint. So those are the two efficiency being introduced here to reach the time requirements of the things. As we can see, submission was accepted. So that's it for today. Thanks. If you like this video and want more of it, please click the like button, put in some comment if you have anything to ask or say. I will I will definitely come to look at the comment and reply it. Okay? So if you have questions of something that you don't understand, just let me know. If there is a bunch of questions, maybe sometimes we can go live and then discuss it online. Okay? So hopefully that's useful and fun. And thank you for listening in. Bye.